Alright guys, today we're going to continue our work with solving compound inequalities, but now we are going to progress into OR inequalities. Now OR inequalities are different than AND inequalities. AND inequalities were primarily focused on where the graphs overlapped when something happened at the same time as something else. OR inequalities, it doesn't have to happen that way. It can happen as this can happen or this can happen. So, for example, on number 1, b is greater than 2 or b is less than or equal to negative 3. So, if you choose a number that works for this, then it works. Or if you choose a number that works for this, then it works. So we're going to start again by doing our starter graphs, our helper graphs. So if I have b is greater than 2, I'm going to find 2 on my number line, go above it, and we're going to have an open dot with an arrow going to the right. b is less than or equal to negative 3, so I'm going to find negative 3 on the number line, go above it, and we're going to have a closed dot with an arrow going to the left. Now, when it was AND inequalities, our primary focus was looking to see where those two graphs overlapped. Now, these two graphs do not overlap. When you're working with an OR inequality, you have to take both of these graphs and bring them straight down onto your graph. So I'm going to take this green one, b is less than or equal to negative 3, and I'm going to bring it straight down to my graph. Then I'm going to take this red one, b is greater than 2, and I'm going to bring it straight down to my graph. And that's our final response. Now we just have to write it in set builder notation. So we still start with a set of all b's such that. Now to describe this graph, you have to take it one piece at a time. So I'm going to start with this piece over here on the left. This piece has a closed dot on negative 3 with an arrow going to the left. So to describe that, that's just b is less than or equal to negative 3. Then we don't see anything from negative 3 to 2. There's a big old gap in our graph. When we see a gap, that means we have to actually write the word OR. The gap means we write the word OR. Then I have to describe this left graph over, or this right graph over here with an open dot on 2 and an arrow going to the right. So b is greater than 2. So that means if you pick any number over here or any number over here, it would make this a true statement. You can have one or the other. Okay? On number 2, we have q is greater than or equal to 3 or q is less than or equal to 1. So we're going to start with our helper graphs. Every time we have to do our helper graphs. It's going to be very helpful here in just a little bit. So we'll have q is greater than or equal to 3. So here's 3. I'm going to go over it with a closed dot and an arrow going to the right. Q is less than or equal to 1, so here's 1. Go over it with a closed dot and an arrow going to the left. So again, we're going to take these two graphs and we're going to bring them straight down. So closed dot on 1 with an arrow to the left, closed dot on 3 with an arrow going to the right. And then we write them in set builder notation. So the set of all q's such that. Now I'm going to describe this guy first. So I have a closed dot on 1 with an arrow going to the left. Q is less than or equal to 1. Then I have a gap, so I write the word OR, and then I describe this guy on the right. Q is greater than or equal to 3. Now I know what you're thinking. Why are we doing these helper graphs if they end up looking the same as what we started with? Well, let's look at number 3. On number 3 we have negative 3 is less than d. Well, that can't happen. We have to have the variable first. So let's take a second and let's rewrite that. I want the d on the left side and the negative 3 on the right side. And then here my inequality symbol is pointing to the negative 3, so it still needs to point to the negative 3. So now I have d is greater than negative 3, so I can say that's an open dot on negative 3 with an arrow going to the right. And then d is less than 2, so that's an open dot over 2 with an arrow going to the left. Now this one's a little weird. It looks a lot like our AND inequalities where we were looking for where they overlapped, but this doesn't overlap at all, or this doesn't want us to look where it overlaps. It wants us to put the graphs together. So here's what I'm going to do. We're going to take both of these graphs and graph them directly onto my graph. So let's start with the red one. The red one had an open dot on negative 3 and an arrow going to the right. Then my green graph had an open dot on 2. So if I put an open dot on 2, if you'll notice, there's already an arrow going through that. So what it does is it takes that open dot and it really fills it in. And then that arrow goes to the left. Well, if you'll notice, when my arrow goes to the left, it goes through the open dot from -3, which really fills it in. So I have an arrow on the left, a solid line all the way through, and an arrow on the right. That means all of these numbers work. I want a number that's bigger than -3 or less than 2. So like, let's say I choose the number 5. That's bigger than -3, so it works. Let's say I choose 1. That's smaller than 2, so it works. And it's bigger than -3, so it double works, but it really just works once. Let's say I chose the number -4. It's smaller than -2, so it works. So the key to this is you just have to work for one of them, and it's a solid answer. So to write this in set builder notation, it's a little bit different. We're going to start with the set of all D's, just like normal. But we don't see any gaps in our graph, so we can't write like D is greater than -3 or D is less than 2. And it doesn't like start and stop somewhere, so we can't write it like the and inequalities. But what it does do is it covers all of these numbers, all of these real numbers. So we have to say that D is an element of the real numbers. Now, just a reminder, this element is kind of like a C with a little line in it. That stands for the element of. Okay? All right, on number 4, we have -2 is less than or equal to x. Well, let's take a second and rewrite that. X goes on the left, -2 on the right, and my symbol needs to point to the -2. And then I'm going to graph that helper graph. So closed dot on -2 with an arrow going to the right. Then 3 is less than or equal to x. Well, I need to rewrite that. So x on the left, 3 on the right, symbol pointing towards the 3. So that's going to be a closed dot on 3 with an arrow going to the right. Okay, so again, we want to graph both of these graphs onto my actual graph. So I'm going to start with the red one. It had a closed dot on -2, and my arrow is going to the right over here. Then I'm going to take this green graph and graph it on the same graph. So I want a closed dot on 3, but if you'll look, there's already a line there, so okay, no big deal. Still there. And then the arrow going to the right, but there's already an arrow going to the right, which is kind of crazy. So our final graph really just ends up looking like my original red graph. It doesn't look like that green graph at all. You can't even really see the green graph because the red graph overtakes the green graph. Let's talk about what the red graph was. The red graph was any number bigger than -2, and the green graph was any number bigger than 3. Well, any number that's bigger than 3 is bigger than -2, so this just kind of comes a part of it. So to write it in set builder notation, we want the set of all x's such that, and then I just described this graph. I have a closed dot on -2 with an arrow going to the right, so x is greater than or equal to -2. Alright, on number 5 it says solve each compound inequality, then graph the solution set. So I have -3p plus 1 is less than or equal to -11. So I want to solve by subtracting 1 from each side. And we're left with -3p is less than or equal to -12. I can divide each side by -3. And p is greater than or equal to, because I divided by a negative number, +4. Now I can graph that helper graph. Greater than or equal to 4 is a closed dot on 4 above, with an arrow going to the right. And then my second one here is p is less than 2. So I have an open dot on 2 with an arrow going to the left. Now this is an OR inequality, so I want to take both of these graphs and bring them straight down. So I want an open dot on 2 with an arrow going to the left, and a closed dot on 4 with an arrow going to the right. then we write our set builder notation. So we have the set of all p's such that, I'm going to describe this guy over here, open dot on 2, arrow to the left, p is less than 2. Here's a gap, so we write the word or, close dot on 4 with an arrow going to the right, p is greater than or equal to 4. On number 6, let's go ahead and take a second to solve those. So I have 2x plus 4 is less than or equal to 6, so I'm going to start by subtracting 4 from each side. And I have 2x is less than or equal to 2. Divide each side by 2, and x is less than or equal to 1. And then my guy over here, I want to move all of the x's to the left side, so I'm going to subtract 2x from each side. Now x minus 2x is a negative x, greater than or equal to negative 4. Divide each term by negative 1. And since I divided by a negative, my symbol is going to switch. I'm going to have x is less than or equal to positive 4. So now I have my two inequalities. Let's graph my helper graphs. So x is less than or equal to 1 is going to be a closed dot over 1 with an arrow going to the left. X is less than or equal to 4 is going to be a closed dot over 4 with an arrow going to the left. Now again, we want to take both of these graphs and bring them straight down onto this graph. So if I start with my green graph, I have a closed dot on 4 with an arrow going to the left. And then the red one has a closed dot on 1, which I already have a line there. So if my pen would, I already have a line there, but that's okay. And an arrow going to the left, which there's already an arrow. So really, this green graph overtook this red graph, and I'm just left with the set of all x's such that closed dot on 4 with an arrow going to the left. X is less than or equal to 4. Because any number that's less than 1 is already less than 4. Number 7, we're going to go ahead and solve for n. Oh, here we have a fraction, so to get rid of that, I want to multiply by the denominator. I'm going to multiply the whole thing by 2. So 2 times 1/2 cancels out and just leaves me with 1n is greater than 2 times negative 2 is negative 4. Now on this guy, I want all of my variables on the left side, all of my constants onto the right. So I'm going to subtract n from each side. 2n minus n is 1n minus 2 less than 1. Then I can add 2 to each side, and I'm left with n is less than 3. Now I can graph my two helper graphs. So n is greater than negative 4. It's going to be an open dot over 4 with an arrow to the right. N is less than 3 is an open dot over 3 with an arrow to the left. And I just want to take both of these guys and graph it on my graph. So open dot on negative 4 with an arrow going to the right. And then an open dot on 3, which if you'll notice, there's already a line going through there. So it fills it in with an arrow going to the left. And take note, the arrow going to the left fills this open dot over here. So we're ending up with the full line over here. So that leaves me with the set of all n's such that n is an element of the real numbers. And if you want, you can choose a number to pick and see if it works. So like you just have to have a number that's bigger than negative 4 or less than 3 to make these true statements. So if I were to choose a number that's bigger than negative 4, like 0, it works. If I were to choose a number that's less than 3, like negative 2, it works. Now the two numbers that might give us a little trouble, negative 4 and 3, let's see if it works. So like if I choose the number negative 4, it's not bigger than negative 4, but it is less than 3, so it's okay. Or if I choose the number 3, it's not less than 3, but it is bigger than negative 4, so it's okay. On number 8 and 9, they're giving us the graph. They just want us to write an inequality for it in set builder notation. So we're going to start with the set of, and you can choose whatever variable you want. I'm just going to choose x, so the set of all x's such that, and then we just describe this. I have an open dot on negative 2 with an arrow going to the left, so that's going to be x is less than negative 2. I have a gap, so I write the word or. And then I have a closed dot on 1 with an arrow going to the right, so x is greater than or equal to 1. Alright, what I'd like you to do is pause the video and do number 9 on your own. Alright, hopefully you got the set of all x's, or whatever variable you chose, such that x is less than -1 or x is greater than 2. Okay, next it says define a variable, write an inequality, and solve each problem. So it says, number 10, a number decreased by 2 is greater than 4 or at least 9. So we have to take this one step at a time. So let's start with the first part of the sentence. A number, well, I don't know what that number is, so I'm just going to call it x, decreased by, so that means minus, 2 is greater than, so that's a pretty straightforward symbol. It's going to be is greater than 4. So that gives us one inequality right there. But then it has the word or, so it really means we're going to be working with two inequalities. Now notice what comes after the word or is just at least 9. So I'm going to bring this first inequality down. I have x minus 2 is greater than 4. Then I have that special word or. Now my second inequality just says at least 9. It doesn't say what's at least 9. When that happens, they really mean whatever was on the left side of the inequality symbol over here. So over here on the left side I just had x minus 2. So again I'm still just going to have, oh nope, I take that back. I apologize. They're just talking about, no, you're right, yeah. My goodness, what a day. So they're talking about whatever was on the left side of that inequality sign. So here I have on the left side of the inequality sign x minus 2. So that's going to stay over here, that x minus 2. Then we're going to finish it with this guy over here. Now over there they have at least to represent the symbol. Now remember that was kind of backwards from what we would think it would be. At least means greater than or equal to, and then it's going to be 9. So here you have your two inequalities. All we have to do now is solve. So on x minus 2 is greater than 4, we can add 2 to each side. And we're going to be left with x is greater than 6. And x minus 2 is greater than or equal to 9. We can add 2 to each side. And we get x is greater than or equal to 11. So our final result is x is greater than 6 or x is greater than or equal to 11. Now we don't have to write it in set builder notation because they don't give you graphs, and it's really hard to write these in set builder notation without the graphs to help you. So let's try this again. Maybe this time I won't botch it. So it says the sum of a number and 3 is less than 8 or is more than 12. So I'm going to take this one step at a time. The sum, so we're going to be adding a number, which I don't know what it is, so I'm going to call it x, and 3. So I know that that's going to be written as x plus 3 is less than, so is less than is pretty straightforward, 8. 8 is the final result on that one. So x plus 3 is less than 8. Or, so I've got that fancy word or there, I'm going to go ahead and write it down, is more than, so again that's pretty straightforward, 12. So I want to take whatever was on the left side of the first inequality sign. So whatever came before that first inequality symbol is going to be on the left hand side. So x plus 3, and then I'm going to put it with my new symbol and whatever comes after that. So what I'd like you to do now is pause the video and solve those two inequalities. So when you subtract 3 from the left side, you should get x is less than 5, and subtract 3 from the right one, you should get x is greater than 9. Alright, one more time. On number 12, a number plus 1 is greater than -5 and less than 3. So my first guy here says a number, which I don't know what it is, so I'm going to call it x, plus 1, well that's pretty straightforward, is greater than, that's a nice easy symbol to work with, -5. So my first inequality is going to be x plus 1 is greater than -5. Then we see the word and instead of or. Well, that's okay, so we just write down the word and. Less than, well, less than, again, is a straightforward symbol, 3. So I want to take whatever was before the inequality symbol, so that x plus 1 is less than 3. So if I solve my first inequality, x plus 1 is greater than negative 5, I can subtract 1 from each side, and x is greater than negative 6, and I can subtract 1 from each side, and x is less than 2.